322 feet of steel and fuel lifting off the pad. For the first time in half a century, a crewed spacecraft leaves low Earth orbit. On board are 4 astronauts, including pilot Victor Glover. They represent the current face of American spaceflight, marking the first time a woman, an African American, and a Canadian have headed into deep space. They are flying 240,000 miles to reach the moon, but on this mission, they are forbidden from touching it. Their flight path takes them in a tight loop around the lunar surface before immediately returning to Earth. The Apollo missions proved we could land, plant a flag, and leave within a few days. But those short-duration trips used hardware that wasn't designed for the long-term life support required to actually live on another world. NASA's current objective is to bridge that gap by building a permanent lunar outpost. This base would serve as a self-sustaining laboratory and a staging ground for future missions to Mars. To make that permanent presence possible, the agency needs a highly reliable vehicle for deep space transport. Artemis II is the high-stakes stress test of the Orion capsule, the specific vehicle tasked with keeping crews alive during that transit. Escaping Earth's gravity requires an immense initial push. It takes roughly 6 million pounds of thrust to shove this hardware through the atmosphere. Once the solid rocket boosters drop away, the environment changes instantly. The crew is left inside a compact pressurized module they've nicknamed Integrity. For 10 days, 4 adults live and work in a space roughly the size of a 6-person camping tent. In zero gravity, daily routines require specialized mechanical workarounds. The kitchen is a briefcase-sized food warmer, and when it's time to rest, the crew sleeps in vertical bags tethered to the cabin walls. This diagram shows the mechanics of the onboard gym. To prevent muscle and bone loss and weightlessness, the astronauts must pull against a spinning flywheel to create the resistance their bodies need. Mission Control spends the first day of the flight monitoring these systems in Earth orbit. Proving the life support is flawless is a mandatory requirement before they are cleared to push into deep space. Crossing the 240,000-mile gap to the moon depends entirely on the laws of orbital mechanics. This model shows the maneuver. Utilizing Earth's massive gravity well, precisely timed thruster burns slingshot the capsule toward the moon. That momentum carries them entirely around the lunar surface, traveling further into space than any human in history, seeing the moon's far side. Once they clear the moon's orbit, Earth's gravity takes hold again, reeling the capsule back in at high speed. The vehicle hits the upper atmosphere at nearly 25,000 miles per hour. Friction generates a layer of superheated plasma, and the capsule's heat shield must deflect temperatures reaching 5,000 degrees to keep the astronauts safe. If the shield fails, the mission is lost. Surviving the Pacific splashdown is the definitive metric for the success of the entire Artemis program. A successful splashdown changes the status of the Orion spacecraft. It graduates from an experimental prototype to the official deep space workhorse for the United States. The presence of Canadian mission specialist Jeremy Hansen highlights the logistical reality of modern spaceflight. It is an international effort, with multiple space agencies now sharing the high costs and technical risks of deep space exploration. This iconic image from the Apollo era represents a goal achieved, proving that we can visit a desolate world and return home safely. The hardware currently being tested is designed for a permanent lunar presence. These systems must support a self-sustaining environment where crews can survive the months of isolation required for a future journey to Mars. 60 years ago, we proved we could reach the moon. Artemis II is the required stepping stone to prove our technology can support us long enough to stay there.